All right, guys, as promised, a quick guide to a couple of your homework problems in case you're still struggling from today. We're looking at electron configurations and electron orbitals. We talked about in our POGL. You guys saw the 1s, 2s, 2p, 3s, and 3p sublevels. And then I talked about on the board really quick that these actually get filled up in a kind of odd order as we get into the higher level sublevels. So we do start out with 1s, and then we're going to fill in 2s, and then we're going to fill in 2p, then 3s, then 3p, then 4s. We're going to skip 3d and go to 4s. It's actually lower energy than 3d. Then go to 3d, 4p, 5s, 4d, 5p, 6s. So I just want to show you guys that process one more time, right? That we kind of go in an odd pattern here when we're dealing with the d orbitals of higher level groups. So we're going to start off our example with argon, which argon's atomic number is 18, which we know means that argon has 18 protons. When we're doing electron configurations, unless stated otherwise, we're assuming that we're dealing with a neutral atom. So if we have 18 protons, we're going to have 18 electrons. So we need to figure out where our 18 electrons go. I'm going to start with the boxes, kind of in the same format that you guys are seeing. So at the base, our lowest energy, we're going to have a 1s sublevel. Then in our next level up, we're going to have 2s with one orbital in it, and then 2p with 3 orbitals. Then we'll go to 3s, then 3p. And I'm just going to draw it up till there for now. So with argon, our 18 electrons, we start at 1s. That's our lowest energy. We will always fill in an up electron first. We want to fill in our orbital. We want to fill in our sublevel before we move to another sublevel. We'll add down. That's 2 electrons that we filled in. Then we're going to move up to 2s. We're going to fill in our ups first. We have finished all the ups in our sublevel. Then we're going to move and fill in our down arrows. Okay. So we have 4 electrons so far that we've filled in. Now we're in 2p. We're going to fill in an up in each orbital, and then go back through and fill in our downspin electrons in those same orbitals. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I move up to my next level, which is 3s. Up, down, gives me 12 electrons that I filled in so far. 13, 14, 15, 16, 17, 18. So this is for our arrows. And then when we actually write that out like that manager's code, it's going to be 1s, 2, right? I have 2 arrows in the 1s sublevel. 2s, 2, 2p, 6, 3s, 2, 3p, 6. Argon is found on the far right side of our periodic table. It is what we call a noble gas, which means that it has a full set of orbitals. It doesn't actually need to do chemistry with anybody because it's happy all by its lonesome. All of its orbitals are full. Okay, next. Phosphorus has 15 protons. Its atomic number is 15, so we're also going to have 15 electrons. I'm going to go in the same order. I'm going to fill in that same format. And there is our arrow diagram for phosphorus. And then our electron configuration would be 1s2, 2s2, 2p6, 3s2, and 3p3, because I only have 3 electrons in that 3p sublevel. For lithium, our atomic number is 3. If you've been following along, you know the order of our electron configuration is going to go 1s, 2, right? We're going to fill that guy up first. And then we know next comes 2s. So it would be 2s1 because we only have 3 electrons. 2 will go in the 1s orbital and 1 will go into the 2s orbital. I have, write it bigger, 1s2, 2s2, 2p4. Remember our exponents here, just like you figured out in your POGL. These are my electrons. So if I add those up, 2 plus 2 plus 4, I know that this atom has 8 electrons. Like I said, unless stated otherwise, we're going to assume that it is a neutral atom. When I look at my periodic table of elements, I know that 8, my atom with 8 protons, therefore 8 electrons, is going to be oxygen. So for our second half, what you need to be doing is adding up the number of electrons. We know that our number of electrons is going to be equal to our number of protons, as long as that atom is neutral, that we're not looking at an ion. And then you can figure out what you got.